The first 9 by 12 inches manila paper will be used to lessen the impact. Maximum area will be utilized for greater resistance, thus it will not be folded. On each opposite corner, there will be holes where the yarn will sooner be inserted. This yarn will attach both materials. The other 9 by 12 inches manila paper will be used to wrap around the egg. This paper will be its protective shield. On the upper section of this paper, 2 holes will be cut to insert the yarn. The circumference will be 2 inches. The paper beneath the egg shall be twisted to serve as cushion, for this part will hit the ground first. It will also be wrapped by tape since manila paper is easily bent and thin. The tape could give it support to withstand the impact.
What are the materials needed? First, manila paper. Second, yarn. Third, tape. Fourth, egg. First, we are going to cut the manila paper into 2 parts. Second, we are going to fold into half the other part of the manila paper. Then, make a small hole on the upper left corner. Then set aside. Then, put the egg in the center and wrap it using the paper. After that, twist the right side of the paper and make a small hole on both sides. Then, insert the yarn in all the small holes. After that, tie the both ends of the yarn. Also, wrap the lower portion with the tape to secure it even more.
Manila paper is made of the yellowish-brown fiber and used to support the egg. It can also be used as parachute because it is lightweight and can easily be flown by air. Yarn is made of fiber and tape, typically made with a polyvinyl chloride backing and a non-corrosive rubber-based adhesive. The 2 of them were just used to have strong framework of the improvised parachute for the egg. Eggs have thick shells that can withstand or support strong forces. The chicken eggshell is made almost entirely of 95 to 97% calcium carbonate crystals, which are stabilized by a protein matrix. Without a protein, the crystal structure would be too brittle to keep its form, and the organic matrix is thought to have a role in deposition of calcium during the mineralization process. The other components include organic matrix, magnesium, phosphorus, and a variety of trace elements.
The objective of this instrument is to ensure that the biological weapon will not break when dropped, and we used the egg drop experiment to test our instrument. We tested the instrument at a 1 and 2 meter height and at the second floor of the house. The objective of the egg drop experiment is to keep the egg from breaking as it decelerates. But in order to minimize the force experienced by the egg at impact, we need to increase the time over which the egg is brought to rest or decrease the egg's velocity at the time of the crash. In order to decrease the egg's velocity upon impact, we must design our egg carriers to have increased air resistance. An increased surface area on the carrier, such as the paper parachute that we use to hold the egg, will cause the egg to hit the ground at a lower speed. But since Manila paper is thin and can be arched easily, we use tape to hold the pieces together and withstand the impact of the egg dropping. And we also designed a cushion that will protect the egg from touching the ground first, hence making a lesser impact for the egg.